Lesson 4.7, kind of a challenging one here. A function made of two or more equations. So we're graphing multiple lines on the same graph based on the domain. So depending on the x values. So a piecewise function roughly might look something like this. Okay. So this equation would happen when x is less than 0. This equation would happen when x is greater than or equal to 0. That's what it means by based on the domain. So let's take a look at a piecewise function and see exactly how we use those x values to determine which equation we're using. This is what a piecewise function looks like. F of x equals, and we got this French brace that means it equals all these things. So at one point it equals x minus 2, but we would only ever use that equation when x is less than or equal to 0. At another point it equals 2x plus 1, and we would only ever use that when x is greater than 0. So we really have two equations that are going to end up on this graph. Y equals x minus 2, and y equals 2x plus 1 at these different points. So for letter A, which one of these accepts 0 in its domain? Well, 0 is the comparison point, but the top one has the or equal to sign. So we're going to use the first equation. F of 0 uses 2x, or uses x minus 2. So now we plug it in. F of 0 equals 0 minus 2. 0 is what got plugged in for x. 0 minus 2 is just negative 2. So this is the solution. The function at 0 is negative 2. When we plug 0 into the function, we get negative 2. For letter B, f of 4 uses the second equation, 2x plus 1, because 4 fits the x greater than 0 scenario. All right, so f of 4, we'll plug that into the second equation, 2 times 4 plus 1. So we're plugging in x. Now let's evaluate. 2 times 4 is 8. 8 plus 1 is 9. All right, so it's just a quick practice at reading piecewise functions. Give us an x value, we have to find which equation to use because there's more than one option, but only one of them is correct, depending on this inequality here. Now we have to do something a little more complicated, which is graph this. So there's this little checklist we're going to make. It's 4 items long. 2 of them are normal. All right. We need the slope and the y-int. Okay, that should be relatively easy for both of these. We've been doing this for a while now. The first equation, negative x minus 4. All right, so let's box this off just so we know it's separate. So for negative x minus 4, the slope is negative 1, and the y-int is negative 4. All right, that'd be the 0.0 comma negative 4. I'm going to write it that way. The second one, it's just x, has a slope of 1 and a y-intercept of 0. Okay, so those are done. Those we've done before. Let's graph these lines. M equals negative 1, starting point of 0, negative 4. Negative 1 means down 1, right 1. We can plot some points backwards too. But we have to think ahead and know we're not going to use this whole graph. There will be things I have to erase. The other two things we need to know, well, let's get the other graph on there too. 0, 0. Slope of 1 means up 1 over 1. Try and do a nice clean job of this. get that line a little straighter. Might have helped if my points were right on. All right. And backwards. And kind of predict where that's going to be. The other things we need are open or closed. And this means the circle because of the inequality. Remember graphing inequalities on a number line, how we had an open or a closed circle? Same thing here. And then whether it goes right or left. Same comparison. Remember graphing on a number line? Depending on the greater than or less than symbol, it went right or left. So for the negative x minus 4, it does not have the or equal to sign. This one should be open. And with the less than symbol, x less than 0, I should be graphing to the left. So my first equation here should only graph to the left of the comparison point and have an open circle. My other equation is going to be opposite of these things, but let's check and make sure. It has the or equal to sign, so that's closed, just like I predicted. And it's x greater than, so it's going to go right. All right. Now, to help paint this picture, let's draw a dashed line at this comparison point. This is the vertical line, x equals 0. And this is where things are changing. It uses one equation to the right of that and one equation to the left. So that's where I'm going to change it to open circles or closed circles. My first equation should have an open circle. So let's change this to an open circle on the graph. And it should only shade left. So I'm going to erase the part where I shaded right. The other one has a closed circle, so I don't have to change that. It's already a nice solid dot. And I should erase the left part because it only goes to the right. And that is a successful piecewise function graph. Another way to do this is check those open, close, left, right things first and only plot the points and go in the direction you're supposed to and not have to erase at the end. So you have two choices. If you can think ahead and know where that line's going to be first, well, maybe you don't have to do any of the erasing. Last problem we're going to be looking at in this video, we're writing the equation for a graph. All right, so we're going to have a similar format to the ones they were giving us. Y equals, and then this stuff. All right. We're going to kind of work backwards. Last time, the last thing I did was checked my open, closed circle, left, right stuff. This time it's going to be the first thing we look at. I'm going to write the if part right away. Okay, so this graph first. It's got an open circle, and it's going to the left at 0. All right, these are both going to compare to 0, because remember my dashed line? Well, it's also splitting on the y-axis. The other one has a closed circle, and it goes right. So it's going to be the greater than or equal to sign. Okay, so this left equation is my top one in the piecewise function. So what's nice about being at 0 is I can find my b value. This one has b equals 3. So it's going to be an mx plus b, but I know b is 3 already. We just need to find this slope. If we count, it's going down 1, left 1 to the next point. Well, what's negative 1 over 1? Negative 1 over negative 1? That's just 1. So that's my slope, 1x plus 3. Okay, these are all skills we should have from other lessons that we have to rely on here. This lesson really brings a lot of stuff from this year together. The next equation starts down 1. That's a b of negative 1. So it's going to be mx minus 1. I still need my slope, though. This one is going up 2, right 1. So it's a slope of 2 over 1, or just 2. Okay. So it's the same checklist, just backwards. We have to find it from the graph. We need b, the y-intercept, m, the slope, whether it's going left or right, to get our inequality symbol, and whether it's open or closed to decide which one gets the or equal to sign. So it's the same checklist, just backwards. This definitely isn't the easiest problem we've done all year. I'd say actually consistently and successfully doing this is probably the hardest actual math problem we've had to do this year. It's a lot to keep track of and a lot of things you have to know. So there's examples on the practice and there'll be examples on the review. This one is worth practicing. Review's like 3 different units. It's a pretty good one to learn if you're really trying to get good at this class.